Hello students, I welcome you all in Rayat Shikshan Samstha's ROSE project conducted by Yashwantrao Chauhan Institute of Science, Satara. This is second lecture of the chapter Structure of the Atom. Now, in this lecture, we are going to study the different atomic models. Now, observations obtained from the experiments of discovery of subatomic particles suggested that Dalton's individual atom is composed of a subatomic particles carrying positive and negative charges. Means what? कि Dalton's theory होती, in that theory, Dalton said that कि atom is an individual particle. Means atom is an individual. त्याला आपण divide करू शकत नाही. परंतु there are many observations obtained from the experiments of discovery of a subatomic particle. After the discovery of subatomic particles like electrons, protons, and neutrons, we are saying that the atoms is containing the positively and negatively charged particles. Now, why there is a need to discover the different atomic models to account for the stability of atoms, to compare the behavior of elements in terms of both physical and chemical properties, to explain the formation of different kinds of molecules by the combination of different atoms, and to understand the origin and nature of the characteristics of the electromagnetic radiations absorbed or emitted by the atoms. There are different atomic models were studied as follows. So, why the different atomic models were studied? To account for the stability of atoms, to compare the behavior of the elements in terms of both physical and chemical properties, then to explain the formation of different kinds of molecules by combination of different atoms. म्हणजे molecules कसे तयार होतात when atoms are combined, or to understand the origin and nature of the characteristics of the electromagnetic radiation. हे सगळ्या properties किंवा हे सगळे points explain करण्यासाठी different atomic models study केले गेले. ज्या atomic model मध्ये first atomic model होतं Thomson model of a atom. So J.J. Thomson in 1898 proposed that an atom possesses a spherical shape in which the positive charge is uniformly distributed. The electrons are embedded in it in such a manner as to give the most stable electrostatic arrangement. Now here you can see the picture which represent the Thomson model of atom. Now many different names are given to this model. For example, plum pudding model, or the resin pudding model, or the watermelon model. Now this model can be visualized as the pudding or the watermelon of a positive charge with the plums or seeds embedded into it. म्हणजे simply कसं आहे बघा की watermelon, suppose you compared the watermelon as a atom. मग atom मध्ये जो रेड कलर पार्ट असतो वॉटरमेलनचा तो म्हणजे काय असणार आहे तर पॉझिटिव्ह चार्ज किंवा पॉझिटिव्ह स्फिअर, अँड द ब्लॅक कलर सीड्स ऑफ दॅट वॉटरमेलन्स इज नथिंग बट द इलेक्ट्रॉन्स विच आर एम्बेडेड इन दॅट रेड कलर पार्ट. सो वॉटरमेलनचा जो रेड कलर पार्ट असणार आहे तो म्हणजे पॉझिटिव्ह चार्ज असेल, आणि त्यांच्यामध्ये एम्बेडेड केलेल्या ज्या सीड्स असतील ते म्हणजे काय असेल इलेक्ट्रॉन्स असतील. सो इन दिस वे ही कम्पेअर्ड द स्ट्रक्चर ऑफ द ॲटम with the watermelon or the plum pudding. An important feature of this model is that the mass of the atom is assumed to be uniformly distributed over the atom, although this model was able to explain the overall neutrality of the atom but was not consistent with the results of the latter experiment. So basic what explained by the Thomson model is the neutrality, overall neutrality of the atom. But whatever next experiments was done, that properties of the atom or the structure of the atom were detailed not studied by the Thomson model, and that is why the next one model is put forth, which is the Rutherford's nuclear model of an atom. So Rutherford and his students like Hans Geiger and Ernest Marsden bombarded very thin gold foil with the alpha particles. Now Rutherford's alpha particles alpha particle scattering experiment जो आहे, so you can see here the diagram of that experiment. What you can see here, this is the source of alpha particle, then here is one lead plate is placed here, and curve shaped gold foil, one gold foil is there here, yellow colored gold foil is there, and around which a curve foil is photographic plate is placed there. Okay, so this is the arrangement of this experiment. A stream of high energy. What happened in this experiment? A stream of high energy alpha particles from a radioactive source was directed at a thin foil, which having the thickness approximately 100 nanometer of gold metal. The thin gold foil had a circular fluorescent zinc sulfide screen around it. याच्या भोवती काय होती तर झिंक सल्फाइडची फोटोग्राफिक प्लेट होती स्क्रीन या गोल्ड फॉइलच्या भोवती. Whenever alpha particles struck the screen, a tiny flash of light was produced at that point. म्हणजे काय व्हायचं की या अल्फा सोर्स मधून ज्यावेळेला रॅडिएशन्स बाहेर पडायचे लेड प्लेट मधून ते बंबार्ड होऊन ज्यावेळेला थीन गोल्ड फॉइल वरती बंबार्ड व्हायचे त्यावेळेला त्याच्यामधून काय व्हायचे की काही टायनी फ्लॅश ऑफ लाईट त्या फोटोग्राफिक प्लेटवर, जसं की इथं तुम्ही डायग्राम मध्ये बघू शकताय की याच्यातून जे काही इमिशन व्हायचं रॅडिएशन झालेलं आहे ते ज्यावेळेला फोटोग्राफिक प्लेटवरती बंबार्ड व्हायचं किंवा आपटलं जायचं त्यावेळेला काय व्हायचं थोडासा टायनी लाईट फ्लॅश असा दिसायचा. तर इथं फ्लॅश शो केलेला आहे. नाउ फ्रॉम दिस एक्सपेरिमेंट Rutherford having some observations of this experiment. Now what is that observation? First observation is that most of the alpha particle pass through the gold foil undeflected. जे बरेचसे अल्फा पार्टिकल काय झाले तर अनडिफ्लेक्टेड राहिले. Then second one observation is that a small fraction of the alpha particle was deflected by a small angle. अगदी थोडे अल्फा पार्टिकल काय झाले तर अगदी थोड्या स्मॉल अँगलनं डिफ्लेक्ट झाले. अँड थर्ड वन ऑब्झर्वेशन इज दॅट अ व्हेरी फ्यू अल्फा पार्टिकल मीन्स अप्रॉक्सिमेटली 1 in 20,000 मधला एक पार्टिकल असे अगदी कमी पार्टिकल्स काय झाले बाउन्स बॅक दॅट इज डिफ्लेक्टेड बाय नियरली 180 डिग्री अँगल. म्हणजे पूर्णपणे परत फिरले 180 डिग्री मध्ये ते काय झाले डिफ्लेक्ट झाले. मग आता हे जे ऑब्झर्वेशन होते फ्रॉम दॅट ऑब्झर्वेशन रुदरफोर्ड कन्क्लुडेड दॅट first conclusion is that most of the space in the atom is empty as most of the alpha particles pass through the foil. Okay, first observation काय होतं की most of the alpha particle pass through the gold foil. गोल्ड फॉइल मधून बरेचसे अल्फा पार्टिकल काय झाले पास झाले. मग का पास झाले तर त्याचं कन्क्लुजन काय होतं की मोस्ट ऑफ द स्पेस इन द ऍटम इज एम्प्टी. बराचसा पार्ट काय आहे एम्प्टी आहे ऍटम मधला आणि म्हणून अल्फा पार्टिकल काय होतात अल्फा पार्टिकल पास थ्रू द फॉइल. Now second one conclusion is that a few positively charged alpha particles were deflected and the deflection must be due to enormous repulsive force showing that the positive charge of the atom is not spread throughout the atom and the positive charge has to be concentrated in a very small volume that repelled and deflected the positively charged alpha particle. Alpha particle हे कसे आहेत बेसिकली पॉझिटिव्हली चार्ज आहेत आणि अकॉर्डिंग टू थॉम्सन मॉडेल काय सांगितलं होतं की पॉझिटिव्ह चार्ज हा काय झालाय तर ओव्हरऑल त्या ऍटम मध्ये स्प्रेड झालेला आहे. परंतु अकॉर्डिंग टू रुदरफोर्ड जर काही अल्फा पार्टिकल अगदी स्मॉल अँगल मध्ये डिफ्लेक्ट होत आहेत याचा अर्थ की पॉझिटिव्ह चार्ज हा होल अख्ख्या ऍटम मध्ये स्प्रेड न होता कुठेतरी एका ठिकाणी काय झालेला आहे कॉन्सन्ट्रेट झालेला आहे. Okay, so the deflection must be due to enormous repulsive force showing that the positive charge of the atom is not spread throughout the atom and it is concentrated in a very small volume. So this is the second conclusion. And third one conclusion is that calculations by the Rutherford showed that the volume occupied by the nucleus is negligibly small as compared to the total volume of the atom and the radius of the atom is about 10 raised to minus 10 meter while that of the nucleus is 10 raised to minus 15 meter. So जे कॅल्क्युलेशन केले गेले रुदरफोर्डनं आफ्टर दॅट कॅल्क्युलेशन ही शोड दॅट की व्हॉल्यूम ऑक्युपाइड बाय द न्यूक्लियस volume occupied by the nucleus is very negligible and it is small as compared to the total volume of the atom. पूर्ण जर ऍटमचा व्हॉल्यूम कन्सिडर केला तुम्ही तर त्यापैकी अगदी कमी जागेमध्ये काय आहे तर ऍटमचा न्यूक्लियस आहे. सो दीज आर द कन्क्लुजन्स रिगार्डिंग द स्ट्रक्चर ऑफ ऍटम बाय रुदरफोर्ड. नाउ फ्रॉम दिस ऑब्झर्वेशन्स अँड कन्क्लुजन he put forth some postulates that is postulates of a Rutherford's atomic model. So first postulate is that the positive charge and the most of the mass of the atom was densely concentrated in extremely small region. This very small portion of the atom was called as a nucleus by Rutherford. Then second one postulate is that the nucleus is surrounded by electrons that move around the nucleus with a very high speed in a circular path and called as a orbit. And thus Rutherford's model of an atom resembles the solar system in which the nucleus plays the role of sun and the electrons that of the revolving planet. म्हणजे काय तर रुदरफोर्डचा जो सेकंड पोस्टुलेट होतो, अकॉर्डिंग टू दॅट पोस्टुलेट न्यूक्लियस हा काय आहे ऍट द सेंटर आहे आणि इलेक्ट्रॉन्स त्या न्यूक्लियस भोवती एका सर्क्युलर पाथ मध्ये काय होत आहेत रिव्हॉल्व्ह होत आहेत. या सर्क्युलर पाथला काय म्हणायचं तर ऑर्बिट. आणि मग जर हे स्ट्रक्चर आपण कन्सिडर केलं तर दॅट स्ट्रक्चर विल बी रिझेम्बलन्स विथ द सोलर सिस्टम in which the nucleus is like a sun and the electrons are like a revolving planets. Okay, and third one postulate of the Rutherford's atomic model is electrons and the nucleus are held together by an electrostatic force of attraction. So nucleus, you know that in a nucleus protons are there which is positively charged and electrons are negatively charged particles. So that is why you can say the electrons and the nucleus are held together by a electrostatic force of attraction. So this is the third postulate. So these are all about the atomic model of the Rutherford. Okay, now as there are many postulates of the Rutherford's model, instead of that some drawbacks are there in a Rutherford atomic model. In that, first one drawback is that it does not define the stability of an atom and it's a discrete spectrum. So पहिलं जे ड्रॉबॅक होतं त्याच्यातलं की ॲटमची स्टॅबिलिटी रुदरफोर्डचं मॉडेल एक्सप्लेन करत नव्हतं. त्याचबरोबर डिस्क्रीट स्पेक्ट्रम जो आहे तो सुद्धा रुदरफोर्ड मॉडेलनुसार एक्सप्लेन केला जात नव्हता. आणि सेकंड वन ड्रॉबॅक आहे इट डज नॉट डिस्क्राइब द डिस्ट्रीब्युशन ऑफ इलेक्ट्रॉन्स अराउंड द न्यूक्लियस अँड देअर एनर्जीज. सेकंड ड्रॉबॅक काय आहे तर रुदरफोर्डने फक्त सांगितलं की न्यूक्लियसच्या भोवती इलेक्ट्रॉन्स रिव्हॉल्व्ह होत आहेत इन अ सर्क्युलर पाथ, परंतु एक्झॅक्ट इलेक्ट्रॉनचं डिस्ट्रीब्युशन कसं असणार आहे त्या सर्क्युलर पाथ मध्ये दॅट डिस्क्रिप्शन किंवा distribution of electrons are not given by a Rutherford atomic model. So these are the drawbacks of Rutherford's atomic model. As there are drawbacks of the atomic model of the Rutherfords, so next one atomic model is put forth. Now the next one model is the Bohr's atomic model. Now this model is studied. Before that, some different studies or the developments leading to the Bohr's atomic model were studied. Now, at the time when different atomic models were being put forth, some results obtained from the studies of interactions of radiation with the matter required to be correlated with the atomic structure. Now, Niels Bohr utilized this result to get over the drawbacks of Rutherford's atomic model. And these results were, first one जो होता तो होता wave particle duality of electromagnetic radiation and the line emission spectra of hydrogen. So we'll see the one by one. First one is the wave particle duality of electromagnetic radiation. Okay, means the electromagnetic radiation hoti that will be behaves like a wave also and like a particle also. So this is called as a wave particle duality of the electromagnetic radiation. Now interaction of radiation with the matter is correlated to the atomic structure by the Niels Bohr. Now when light interacts with the matter, it behaves as a stream of particles called as a photons. Now when light propagates, it behaves as an electromagnetic wave. Means when light will propagate, it will transfer, it will behave like an electromagnetic wave. Now you can see here the diagram of that wave, and we will study this wave in a electric field and magnetic field, and these two fields are perpendicular to each other. Now you can see here the crest and troughs and the traveling direction of the wave. Okay, now as the light propagates and it behaves like an electromagnetic wave, we will see some characteristics of the electromagnetic wave. Now, which are that characteristic? In that, first one characteristic is the wavelength, which is denoted with the letter lambda. What is wavelength? The distance between two conjugative crests or the troughs is called as a wavelength. Consecutive crest किंवा troughs मधलं जे distance आहे that is called as a wavelength. It's a SI unit is a meter. SI unit of a wavelength is a meter. Now second one characteristic of the electromagnetic wave is a frequency, and it is denoted with the letter nu. The number of waves that pass a given point in 1 second is called as a frequency. It's a SI unit is a hertz. Now third one characteristics of an electromagnetic wave is the wave number. It is denoted with the letter nu bar. Now wave number is the number of wavelengths per unit length, and it's a SI unit is a per meter. Fourth one property, or you can say the characteristics of the electromagnetic wave is the amplitude. It is denoted with the letter capital A. Now amplitude of the wave is the height of the crest. So whatever crest you can see in the wave, electromagnetic wave, its the height is nothing but the amplitude of that wave. So these are the four characteristics of the electromagnetic radiation. Now we will discuss the particle nature of the electromagnetic radiation. As we studied the wave nature of electromagnetic radiation, पहिल्यांदाच मी तुम्हाला सांगितलं होतं की electromagnetic radiation will behave like or will show the dual nature. Means it behaves like a particle, also it behaves like a wave. आणि मग जर इलेक्ट्रोमॅग्नेटिक रेडिएशन वेव्ह सारखं नेचर शो करतंय तर that is why we have studied its characteristics. Okay, now the particle nature of the electromagnetic radiation. In 1900, Max Planck put forth a quantum theory. Now according to this theory, the energy of electromagnetic radiation depends upon the frequency and not the amplitude. Okay, so electromagnetic radiation जी जी काही एनर्जी असणार आहे ती एनर्जी कशावरती डिपेंड आहे तर इट डिपेंड्स अपॉन द फ्रिक्वेन्सी अँड नॉट ऑन द amplitude. Now Planck gave the name quantum to the smallest quantity of energy that can be emitted or absorbed in the form of electromagnetic radiation. Okay, so electromagnetic radiation च्या फॉर्म मध्ये जी काही एनर्जी इमिट होईल किंवा ऍब्सॉर्ब होईल त्या एनर्जी पॅकेटला किंवा तो जो एनर्जी बंडल असणार आहे that will be called as a quantum. Now the energy E of one quantum of radiation is proportional to its frequency, because first only we have seen that ki electromagnetic radiation ji energy ahe that will be depends upon the frequency. So what is the relation between energy and frequency? The energy of one quantum of radiation is proportional to its frequency, and that relation is given by E is equal to h nu. Okay, where h is the proportionality constant and it is called as a Planck's constant, and its value is 6.626 into 10 raised to minus 34 joule second. Okay, this is the value of Planck's constant h. Now electromagnetic radiation as a stream of photons of energy, which is the h nu. So electromagnetic radiation as a stream of photons, you can say the photons or you can say the energy bundle, quantum to that smallest quantity of energy आपण म्हणतोय तर electromagnetic radiation as a stream of photons. जर आपण stream of photons म्हणलं तर its energy is a h nu. Now the next one point is a photoelectric effect. Now photoelectric effect in the year 1905 अल्बर्ट आइन्स्टाईन होता, त्यानं काय केलं होतं तर he explained the photoelectric effect photoelectric effect using the Planck's quantum theory. So Albert Einstein explained the photoelectric effect using the Planck's quantum theory. But what is photoelectric effect? Photoelectric effect स्टडी करण्यासाठी अल्बर्ट आइन्स्टाईनने काय केलं होतं तर क्वांटम थेअरी यूज केली होती, परंतु क्वांटम थेअरी यूज करण्याच्या अगोदर फोटोइलेक्ट्रिक इफेक्ट हा कोणी डिस्कवर केला तर दॅट विल बी डिस्कवर्ड बाय सायंटिस्ट एच हर्ट्झ इन 1887. So in 1887, H. Hertz performed a very interesting experiment in which the electrons or the electric current were ejected when the certain metals, for example, potassium, rubidium or cesium, etc., were exposed to a beam of light, and the phenomenon is called as a photoelectric effect. काय आहे photoelectric effect? तर 1887 मध्ये H. Hertz ने काय केलं होतं तर काही मेटल्स मग कुठले तर त्याच्यामध्ये पोटॅशियम असेल, रुबिडियम असेल किंवा सीजियम यासारखे मेटल काय केले होते एक्सपोज केले होते टू द बीम ऑफ लाईट. when the metal surface is exposed to a beam of light, the some electrons were ejected through that surface. मग त्यातून काय झाले की त्या मेटल सरफेस मधून काही इलेक्ट्रॉन्स इजेक्ट झाले आणि ही जी फिनॉमिनॉन होती that will be called as a photoelectric effect. Now when the photoelectric effect, that experiment was studied, some results observed in this experiment. What are that observation or the result? The first one is that the electrons are ejected from the metal surface as soon as the beam of light strikes the surface. That is, there is a no time lag between the striking of light beam and the ejection of electrons from the metal surface. म्हणजे काय बघा की ज्या वेळेला मेटल सरफेसला ती बीम ऑफ लाईट काय होती स्ट्राईक होतीये, म्हणजे as soon as the beam of light will strike to the surface of metal, the electrons are ejected. म्हणजे ज्या क्षणी ते काय होणार आहे, ती बीम ऑफ लाईट त्या मेटल सरफेसवर काय होईल, बीम ऑफ लाईट स्ट्राईक करेल तेव्हा लगेच त्याच्यातून काय होणार आहे, इलेक्ट्रॉन्स इजेक्ट होणार आहे. देयर इज अ नो टाइम लॅग बिटवीन द स्ट्रायकिंग ऑफ लाईट बीम अँड द इजेक्शन ऑफ इलेक्ट्रॉन. अगदी क्षणार्धात आपण म्हणतो त्या पद्धतीने क्षणार्धात त्यातून काय होणार आहेत, इलेक्ट्रॉन्स इजेक्ट होणार आहेत. नंतर सेकंड वन रिझल्ट होता की द नंबर ऑफ इलेक्ट्रॉन्स इजेक्टेड इज प्रोपोर्शनल टू द इंटेन्सिटी ऑर द ब्राईटनेस ऑफ लाईट. जेवढी इंटेन्सिटी जास्त तेवढे काय असणार आहेत, नंबर ऑफ इलेक्ट्रॉन्स इजेक्टेड असणार आहेत. म्हणजेच काय, the number of electrons ejected is proportional to the intensity or the brightness of light. Okay. Third one result hota ki for each metal there is a characteristic minimum frequency nu zero, which is also called as a threshold frequency, below which the photoelectric effect is not observed. Okay. प्रत्येक मेटल साठी एक कॅरेक्टरिस्टिक मिनिमम फ्रिक्वेन्सी आहे, तेवढ्याच फ्रिक्वेन्सीला काय होणार आहे, फोटोइलेक्ट्रिक इफेक्ट शो होणार आहे. After that, below that frequency, you cannot see the photoelectric effect for that particular metal. So each metal have a characteristic minimum frequency, and that frequency is called as a threshold frequency. Now at frequency nu zero greater than nu zero, the ejected electrons come out with the certain kinetic energy, and the kinetic energy of these electrons increase with the increase of frequency of the light used. मीन्स व्हॉट बघा की ज्या वेळेला इलेक्ट्रॉन्स त्याच्यामधून इजेक्ट होतोय, बाहेर पडतोय, याचा अर्थ तो मुव्हिंग आहे. सो इट विल हॅव सम कायनेटिक मोशन. as it will have a kinetic motion means it will containing the kinetic energy. So whatever electrons are ejecting from the surface of that metal, they will possess or they have some kinetic energy, and this kinetic energy of that electron increases with the increase of frequency of light. म्हणजे जशी लाईटची फ्रिक्वेन्सी वाढेल तशी त्या इलेक्ट्रॉनची काय होणार आहे, कायनेटिक एनर्जी इन्क्रीज होणार आहे. Now the energy content of the beam of light depends upon the brightness of the light. In other words, the number of electrons ejected and the kinetic energy associated with them should depend on the brightness of light. So main काय आहे की photoelectric effect मध्ये the energy content of the beam of light म्हणजे त्या लाईटची एनर्जी कशावरती डिपेंड असेल तर ब्राईटनेस ऑफ लाईट. म्हणजे जेवढा ब्राईटनेस जास्त तेवढी एनर्जी जास्त असणार आहे लाईट बीमची. आणि ऍज द ब्राईटनेस ऑफ लाईट जेवढा जास्त म्हणजे इन अदर वर्ड्स तुम्ही काय म्हणू शकता, द नंबर ऑफ इलेक्ट्रॉन्स इजेक्टेड and the kinetic energy associated with that electrons is also depend on the brightness of light. म्हणजे जेवढा ब्राईटनेस जास्त तेवढे नंबर ऑफ इलेक्ट्रॉन्स त्या सरफेस मधून इजेक्ट होणारे तो नंबर जास्त असेल आणि तेवढीच त्याची कायनेटिक एनर्जी सुद्धा जास्त असणार आहे. ओके, सो द कायनेटिक एनर्जी अँड द नंबर ऑफ इलेक्ट्रॉन्स इजेक्टेड will be depends on the brightness of light. So this is all about the photoelectric effect.